All right, hello, my name is Brandon Clayton, the Algebra Guy. Today, as you see on your screen, we will be covering circle with area and circumference. So we're going to start off with a brief breakdown of some of the history and the idea behind the circle, but we'll look at some problems at the end talking about how to solve for circumference and area. So let's get started. As you can see, this is a problem working area that we'll work through here in this as well. We're given a radius. But let's start with our questions for today. How to find the circumference and area of a circle. What is radius? What is diameter? And what is pi? You've probably heard of these words if you're watching this video already and want to become more familiar with them, or maybe you haven't and this is your first time, but either way, we'll go over those today. How can we use the approximation of pi? When is that important? And what does that even mean? So let's start here. The properties of a circle have been studied for 2,000 years, so this has been around for a while. Now, although all circles have the exact same shape, their sizes are affected by the length of the radius. And as you can see on your screen, where the radius is this piece that radiates from the center. We'll say that's point C for future reference. And wherever it radiates out to the edge of that circle, we're going to call the radius. So it could be here, but we can also start here and go here. All of these are the radius. Now you can imagine that this distance is going to be the same no matter where you go because it's the center. So if we had a protractor to kind of wrap around here, you'll see that it actually is what makes that circle the circle. It's the same distance from that center. A line segment that passes through a circle center connecting 2 points on the circle is called a diameter. So this piece, let's do it a different color. So right here going through the center and touching the two ends, we call that the diameter. So the diameter is obviously twice as long as the radius, as you can kind of visually see there, because if radius is halfway, the diameter is twice as long. The size of a circle can be measured in two ways. So we can measure it in circumference and area. So if we're talking about the size of the outside, the distance around it, we're going to call it circumference. As you can see, that's the definition for circumference. Now, if we're talking about how much space is taken up, then we're going to call that the area. So what is pi? And this big idea. So you may have been familiar with hearing it as 3.14, or seeing the symbol, but Archimedes discovered that for all circles of different sizes, no matter what the size is, small or large, dividing the circumference by the diameter always gives us the same number. The value of this number is what we call pi. So no matter what, they take the circumference, this distance, and you divide it by the radius, you always come up with the same number because it's telling you something about the relationship between the circumference and the radius. It's never going to change. It's always going to stay the same number, which is 3.14, as we'll later discover here, which is basically saying that the circumference will always be about 3 times bigger than the radius. Every single circle. Isn't that amazing? That's a principle that someone studied. Symbolized by this Greek letter right here, pronounced pi. However, the exact value of pi cannot be calculated since the decimal never ends. So there's a lot of discussion about that, and many have tried by hand and using computer models to come up with the longest decimal they possibly can for pi. And it gets long. I'm talking in the thousands of places, down and down and down and down. It's amazing how far people have taken that, but in essence it just keeps on going 1, 5 and so on and so on, but it never repeats. It's a it's a non-repeating decimal. If we want the exact circumference or area of a circle, we leave the symbol pi. We leave it pi because we can't calculate exactly what that number is, so pi is the best we can say, is leaving it that way. If we want the exact number, we can get an approximation by making it 3.14. Like maybe we'll just cut it off about right there to the hundreds place and say 3.14, and we'll show that with this approximation symbol. We're not going to say equals, but we'll say it's approximately 3.14. That way people know that we didn't measure it perfectly, because we can't, unless we're going to, it'd just be impossible because the number just keeps on going forever. So to show the result is approximate, not exact, so that's how we will use that. And here's some more properties of the circle. R is the radius we talked about. D is the diameter. Circumference, the formula for finding circumference, the distance around this circle is 2 times your pi times whatever the radius is. Now, I want to mention to you, since we're talking about distance around, what do we call it when we have a polygon? And I want the distance around this polygon. So, and we don't say circumference, we say perimeter. So just know that the perimeter of a circle is called circumference. Now you may think of it as perimeter, but it's just a different name for it. And for a polygon, a triangle, square, rectangle, and such, we call those perimeters. Area is the actual part that's on the inside. How much space does it take up right here, this circle? Now, the application for these can be very useful when thinking about how fast a tire is rotating. You can look at how much space it's covering every second, so how many rotations it's making. A lot of use for that, because circles show up in nature in many different places. Wheels is the one I can think of the easiest. Actually, that's not nature, it's something we made. But this circular shape is very common with the globe and with maybe the sun, a ball of gas. So, but this comes up quite a bit. All right, since the diameter is twice the radius, and the way to find the circumference is use the formula circumference times pi d. Why? Because circumference equals 2 pi r. Well, 2 times r is the same thing as just saying diameter. So you could have just got rid of those two and just wrote d. So it's the same thing. All right, let's do an example. What if you had a radius of 10 inches and to calculate the area, how would you do that? How would we calculate area? Well, first we need to remember the formula is area equals pi r squared. And we'll start plugging in what we want. So we're looking for area, so we're giving radius. So we're going to plug that in. And that gives us 10. So that's 10 squared. 10 squared is 100. And now we're going to write our answer as A equals 100 pi. Notice I didn't keep it pi 100 because for just the format, you want to keep the 100 first, just like we write 3x. And we don't write x3. We don't do it that way. This is just the format you want to write in. Now, both are the same because they're both being multiplied, but that's the way you're often going to see those. Let's do a couple of more practice problems. A circle has a radius of 7 centimeters. Let's approximate, and that's a big word we're using here. Approximate, because it's going to change the kind of pi we're using when they say approximate. Let's approximate its circumference and area. So first, let's do the circumference. Circumference, we are reminding ourselves that equals 2 pi r. So now I like to always put my formula up top and work from that. It's so much easier because you have a template in front of you in which to follow. We're looking for circumference. So I'm going to write down my C. We're looking for that. Well, we're given what? Radius. So we're going to do 2. We're going to keep that pi. And we're going to replace our radius with 7. And our next step is simplifying this. So we can do 2 times 7. That's going to give us 14. And we got pi left over. Now they wanted us to approximate. So I actually should have switched pi for 3.14. So I'll do that now and go ahead and multiply those two. 3.14 times 14. 4 times 4 is 6, 5, 12, and then let's erase that. 1 times 4 is 4, 1 times 1 is 1, 1 times 3 is 3, 6, 9, 3, 4. And since we're multiplying, we move this 2 over because that's the total number of places for the decimal on both of those factors, because this one's up here, so that one didn't move. So it should be right there, 43. Circumference equals 43.96. And just a side note here, notice the format that I kept it in. Now, please do this for your teachers or just for yourself because it's so easy to follow this. Oftentimes, you don't have to repeat writing C because at this point we know you're saying equals to C. You can write it the first time. But this is easy to follow to see what happened from one step to another. If you made a mistake, you can go back and fix a particular mistake instead of looking at the beginning and starting all over. And it also helps if someone's mentoring or teaching you to understand where you could have gone wrong. So always try to show your work, but do it in an orderly fashion. That's easy for you and others to follow. So what about area? So area is equal to pi r squared. And let's say we're looking for area, so we're going to keep area. I'm just going to write it again. And we keep in pi, but we did have a radius 2, so now that's 7 squared. 7 times 7 is 49. And I'm left with pi. And they said approximate again. I keep forgetting that we really do need to approximate 49 3.14. And this is why it's important to go back and look at the question. See, when I get here, I always ask myself, did I answer the question? Well, the question was to approximate. And I know they're trying to say, don't give me exactly the answer by leaving it in pi, approximate it. So let's do that. 3.14 times 49. 9 times 4 is 36. 9 times 1 is 9, plus 3 is 12. It's 27, 28. 4 times 4 is 16. 16, I believe goes there. Hold on, I lost my track. Okay, yeah. 4 times 1 is 4, plus 1 is 5, and 4 times 3 is 12. 6, 8, 13, 5, and 1. We're going to move that 2 spaces. 1, 2, and 153 is what we get. Now look at my answer. Let me write that clearly here and make sure that I put the decimal in the right place. But I asked myself, is 50 times 3 about 153? And I think yes, it is. So we did that correctly, more than likely. So we just found our area, and that's how you do it. You can also convert your fraction 22 over 7 to a decimal. If you use your calculator, this decimal will fill up the display shown, and look at what it's going to fill up to be. It's going to fill up to be 3.142857 and so on, 14, because this also can be approximated for pi instead of 3.14. If you have a fraction, it's a lot easier to know what this looks like as a fraction, so you can kind of get an idea of how to multiply it. So when we have a circle with a radius of a given fraction, we can substitute 22 over 7 for pi instead of 3.14. And since 22 over 7 is also an approximation of pi, we will use the approximation symbol to show we have an approximation. You know what? Speaking of that, I did not do that in our last problems, and I should have. And what I mean by that is I didn't use the approximation symbol, and that's hard to remember because we get so used to writing the equal signs. But since they said approximate, I should have been writing an approximation sign like that. That says it's approximately 153 and whatever it is. It's not exactly. So I'm going to try to remember that on this problem. A circle has a radius of 14 over 15. Approximate its circumference and area. So I'm going to make my note down here since I did that twice to approximate. And it's good to do that for yourself when you notice that you're making a common mistake. Is try to give yourself a way to get it right for the next time. All right, so we said we're going to find the circumference and the area. First thing we need to do is write our formula. So what's the formula for circumference? Is C equals 2 pi r. And we're going to approximate this. So before I even get into writing it anymore, I'm going to go 2, and instead of pi, I see we multiplying a fraction. So I'm going to say this is 22 over 7 times my radius, 14 over 15. And this is how we'll proceed. All right, so how do we multiply and simplify this? Because we could just go straight across. Actually, we'll have to multiply this 2 by one of these. So multiplying 2 by, let's say, 14 gives us 22 over 7 times 28 over 15. Now, I don't know if you missed it or understood it. How do we get 28? Because we just multiplied 2 times either one of these factors will be fine, but don't do both. So we're going to double one of these, and it's going to change the answer appropriately. So I just said 2 times 14, and that's the same thing as 2 over 1. So 1 times 15 instead of 15. All right, now I'm going to try to simplify this as much as I can. I notice I have 22, we're going to multiply this. We got 22, and then we have 7 and a 4. So I already know I can see a 7 down here, so I'm going to leave it 7. And we have 7 times 5 times 4. All right, so that's a little bit easier than if I would have tried to go 22 times 8 divided by 7 times 15. So I'm actually doing a multiplication and reducing at the same time. Because look at this. I now see that my 7s are going to cross, my 4s are going to cross, and I'm left with 22 over 5. That's beautiful. Now I can't simplify anymore because it's not a, it doesn't have any common factors. But I'm going to make sure I put my approximation signs here like I saw the note down here to do. All right, a circle has a radius of 42.5 centimeters. Wow, that's a pretty big fraction. So what are we going to do? Well, we're going to do the same thing. Oh, you know what? I did not do the area of that last one. Thank you for that reminder. All right, so we didn't do the area, so let's go back and keep the same number. This time we're going to say area equals pi r squared. So I'll start with my given. And I'm looking for area. Pi, I notice we're going to multiply by a fraction, so I'm going to go and change pi to 22 over 7. And the radius is 14 over 15. And we're going to square that. Oh my, it's going to be a pretty big radius. Can we get out of that somehow? Well, we're going to see. So we're going to have to approximate this. And actually, I'm going to go ahead and start giving my approximations here since I already put in 22 over 7 as an approximated radius. So what we needed to do is square the top and square the bottom and then multiply those numbers by 22. But what I want to try to do is see if we can find the easier way. Why? Because 14 squared is the same thing as 14 times 14. So that makes that a little bit easier. And then we got times 22 up here. And down here we got 7 times 15 times 15. All right, so 7 times 15 squared. We got to square that too. And we can't take out anything here, but I notice I have a 7 down here and I have a 14. So I see that if I do this to the 7, and I can keep this 14 here and 22. And I still have the same numbers, same value. Okay, I just made this 14 to 7 times 2. But now I'm going to rewrite this. And I can cross those out. Actually, I think I may be able to cross more out now that I'm looking at it. Let's see, 2, 7, 2, 3, 5. Well, maybe not. We'll see if I put this back together. So now I have 14 times 22 over, let's say 30. Let's see if we can break 30 down to its prime numbers. And I'm going to break this top into its prime numbers. 7 times 2 is 14 times 2 times 11. And we got 3 times 5 times 10. Times 2. So 3 times 10 is 30. So 3 times 5 times 2 is 30. Now I can see another factor I can take out, which is a 2. I don't have a 3 or 5 on top, so we're going to leave those alone. Let's remultiply what we have left. 11 times 2 is 70. That's 22. 22 times 7 or 1 is 15, so that's 154. 154, and we got 3 times 5, which is 154. 15. So hopefully that's what you got. That's certainly what I got. And now this one. So we're doing the rate of the circumference first. Circumference equals 2 pi r. And I keep checking to see if they're giving me the radius, because if they don't, I'll just do 2 pi d. Just to make it easier. I don't have to cut it in half, then multiply by 2 again. All right, so let's work this one for the radius. It's 2 times pi times the radius, 42.5. Let's just multiply. Oh, are we approximate? Yep, we're going to approximate. So we got to get that pi to an approximate number. All right, so now we can multiply. First, I'm going to multiply my 2 times 3.14 because that's just easier. 6.28. And now we're multiplying that by 42.5. We are going to get some interesting number here. So let's check it out. 6.28 for 2.5. Trying to think, is there another way? Yeah, we could have done it another way. Would have been better. So we could do a fraction here and do 42 and 1/2, change it to a mixed number and multiply that way. That would give us an approximation. So we could do that, but I already got this set up. Let's go ahead and go for it. 8 times 4 is 40. 5 times 2 is 10, plus 1 is 14. 5 is 31. 2, that's 16. And put a 1 there. 2 times 2 is 4, plus 1 is 5. And this is 12. 6 times 2 is 12. All right, we got that placeholder. Now we need 2 more at the next one. That says 4 times 8 is 32. 3. 2 times 2 is 4, plus that is 7. Nope. Did I do 2 times 2? I meant 3. So 4 times 8 is 32. There's my 3. 4 times 2 is 8, plus 3 more is 11. 4 times 6 is 24, plus 1 more is 25. My goodness, look at this number. So we're going to add all that up. 6, 6, and 2. And we're going to count our decimal places in total. 1, 2, there's 2 there, and 1. So there's 3. 1, 2, 3. And I kind of eyeball this 42 times 6 and see if it's about what it should be. 40 times 60 is 240. So this is about right. So that looks good. And actually, let me bring that back up because I just said it's about right. And it is about right. So what should I put as a sign? Approximately 266.88. And I didn't do my area, so let's do our area next. Area is going to equal pi r squared. Area equals, we're approximating. And this time, let's see, should I square it? No, I'm going to use the decimal still, because if I square that big mixed number, it's going to get out of control, it looks like. So we're going to leave it 3.14. And some tests will even just tell you 3, which is so much friendlier, but I'm going to use 0.14 since we're talking about decimals. So 42.5 squared. All right, so let's work that. 42.5 squared is the same thing as 42.5 times 42.5. 5 times 5 is 25. 5 times 2 is 10, plus is 12. 5 times 4 is 20, plus 1 is 21. And let's see, erase these because we got a lot of work to do on this one. I don't want to get confused. 2 times 5 is 10. 2 times 2 is 4, plus 1 is 5. 2 times 4 is 8. And last but not least is 4 times 5. We got to make sure we got a spot here and 2 spots here. So 4 times 5 is 20. 2 times 2 is 4. 4 times 2 is 8. No, I keep messing it up. 4 times, that's 20. So this is going to be a 2. 4 times 2 is 8. Plus 2 more is 10. 4 times 4 is 16, plus 1 is 17. That's 5, 2, 6, 2, 7, 1. And we got 1, 2 decimal spaces, so right here. That's a big number. Then we're going to have to multiply that by 3.14. My goodness. So this is 1726.25 times 3.14. 5 times 4 is 20. 4 times 2 is 8, plus 2 is 10. 4 times 6 is 24, plus 1 is 25. 4 times 2 is 8, plus that is 10. 28, 29. 4 times 1 is 4, plus 2 is 6. Let's erase all that. And do it over again for the next number. 1 times 5, this should be easy, right? 2, 6, 2, 7, 1. Yay for an easy one. Changing colors just because I started that process and it looks kind of good when I change colors, so we don't need that and that. 3 times 5 is 15. 3 times 2 is 6 plus 1 is 7. 3 times 6 is 18. 3 times 2 is 6 plus 1 is 7. 3 times 7 is 21. 3 times 1 is 3 plus 2 is 5. 0, 5, 2, 1. That's 13, 14, 17, 18, 19, 20. 14 plus 6 is 20. That's 22. 4 and 5. Got 4 decimal places. So 1, 2, 3, 4. So they came up with, we should come up with 5,420 with this decimal. Yay. Wow, that was a little of a beast. How to find the circumference and area of a circle. What's the radius, diameter, and pi? How can we use the approximation of pi? So we talked about the approximation of pi either being 3.14 as a decimal or 22 over 7. 22 over 7. So that's how you can use it. And we talked about what these are. Half the circle, the whole circle going through the middle, and pi. How to find circumference and areas. We just worked using those formulas. Thanks for tuning in. My name is Brandon, the Algebra Guy, and I will see you next lesson.